All right, I'm going to get started here on homework number 22, and it's called Exponential Models. All right, and to start off, we're going to be talking about inverse relations and functions, and this is a continuation of our last lesson. And if you remember, the inverse of a function is a function that undoes the operation of the first one. So we're going to go through in these problems, and the directions tell us first to graph each relation and its inverse using your graphing calculator, and to take a picture of each. So, they give us a number 1, they give us y is equal to 2x minus 3. All right, and now we have to find its inverse before we graph it. So we know we're graphing this, but we also want to graph its inverse. And we'd find its inverse by swapping the x and y and then solving for y. Right, to the first step, swap x and y, and the second step, solve for y. All right, so we want to get y by itself. So I'm going to go ahead and add 3, and that gives me x plus 3, not 3x, equals 2y. And then once I'm here, I want to get y by itself. I divide it by 2. I could write it like this and say divided by 2, or just to make sure I'm going to every single term, I could do it that way. All right, so that gives me 1 over 2x plus 3 over 2 equals y. And I'm just going to go ahead and write it where the y is in the front. Y equals 1/2 x plus 3 over 2. Okay, so that is my my inverse of y equals 2x minus 3. So I have y equals 2x minus 3 and y equals 1/2 x plus 3/2. And now I'm going to graph it. All right, so I have my graphing calculator. The first thing that I want to do is I want to turn on my graphing calculator here in the bottom left corner. So click on. All right, from here, I want to graph my two functions that I have. So I have the first one. Well, first I gotta click on y equals in the top left corner, right? And clear out anything that's already in there. And the first one is y equals 2. And this right here, this button, xt theta n, that's x. So 2x minus 3. And enter. Okay, and then in my y2, my second y, I'm going to write inside parentheses, I'm going to put 1/2. Okay, whenever you're doing a fraction, it's best to put inside parentheses like that. 1/2 x plus 3 over 2. Okay, click enter. And then let's go ahead and click graph in the top right corner. All right, and I'm able to graph both functions. Now, a few things that I just want to take into consideration. The first thing is if your graph doesn't look like this, like I don't know, let's say it's like zoomed in like really far and you can't see anything, right? What you would do is you would click zoom 6, and that gives you the standard view. All right, so that would be number 1. All right, let's move on to number 2. Number 2 is y equals 3x squared. All right, so I know I'm going to graph this, and then let's also graph its inverse. So x equals 3y squared. I'm dividing by 3, and that gives me x over 3 is equal to y squared. Now, check this out. If I find the square root of y squared, all right, that means I also have to find the square root of this side over here. It's going to be plus or minus, because remember, with the square root we can find the negative version or the positive version. So just stay with me here. So that's going to give me plus or minus the square root of x over the square root of 3 is equal to y. We don't like having this radical on the bottom, right? So I'm just going to rewrite it right here. Y equals plus or minus square root of x over the square root of 3. We don't like having that radical in there, so the way to get rid of the radical in the denominator is by multiplying everything by root 3 over root 3. It's really just multiplying it by 1. When you multiply root 3 by root 3, you end up getting just 3. And the square root of 3 times x gives you the square root of 3x. So my answer here is y is equal to plus or minus the square root of 3x over 3. Now, that means since I have plus or minus, right, I have a positive version, y equals the square root of 3x over 3, and I have a negative version, y equals the negative square root of 3x over 3. So, this is going to make up your inverse solution. We're going to graph all three of these right now. All right, so in number 2, we went ahead and found our inverse. So we're going to enter our original function, 3x squared. So I can go ahead and I can either click this button right here and I get squared, or I can just do to the power of 2. Either one will work. Okay, and then since I have 2 different functions here for my inverse, I'm say y is equal to the square root of 3x, the square root of 3x, close parentheses, divided by 3, and then once again hit second, and then this button right here for the square root symbol. Make sure you always close the parentheses. It's equal to, before you click it, negative square root of 3x over 3. All right, so let's graph this. I click graph, get my first function, then I get the second one, and then the third one. So it almost looks like we took that parabola, the original function, and moved it on its side. That's what it really looks like. Okay, and that's number 2. All right, for numbers 3, 4, 5, and 6, we're going to go ahead and graph all these on the same plot. So first thing I'm going to do is I'm going to click y equals. I'm going to clear out anything that's already in there. I'm going to read my directions, and my directions say graph each function using your graphing calculator. Take a picture of each. All right, so my first one is going to be the square root of x plus 1. Making sure that when I use the square root symbol as well that I close it. Then I have the square root of x minus 4. And then I also have the square root of x plus 1 all under the radical. And then I have the square root of x minus 4. Okay, and then if I were to graph it, that's my first one, that's my second one, that's my third one, and that's my fourth one. So let's take a look at these graphs. Okay, we have all 4 of them in here, and just take a look at the shape. It looks like almost half of a parabola. And the reason why we don't have the other half is because negative values wouldn't be able to exist. So notice here, if I go into negative values, it all says error, all the errors. If I move that way, in the Y3, it says error. So I have, like, if I'm plotting, I have 0, 1, 1, 2, 2, and then, you know, you see this growth here moving forward. But by clicking second table, you can see what all the points are of each of your graphs, right? Second table. If I just click on the graph, I'm able to see all 4 of my functions that I plotted here. Okay, so what do you get out of this? What's the point of this? Well, one is to recognize what a square root function should look like, right? If you were to plot it and you get a parabola, you know you maybe did something wrong. And the second is to be able to identify that, you know, the square root of x plus 1 really just takes whatever the square root of x graph was and move it up 1, right? The square root of x plus 1 all underneath that radical, that moves it to the left 1. X plus 4 inside the radical, x minus 4 inside the radical, moved it to the right 4. And then x minus 4 outside of the radical moves it down 4. Okay, so that's important to know. And we're going to move right on here to the next few problems. Okay, we're going to do numbers 7, 8, and 9 all together. So I'm going to go and clear these out. Number 7, it says the same exact directions to graph these functions. And the first one is y equals 2 to the power of x. We've graphed y equals x squared, but haven't actually graphed y equals 2 to the power of x. So now our variable is in the exponent. All right, and I also have y equals 6 to the power of x. And then also have 2 times 3. 3 is inside parentheses, it's important, to the power of x. All right, so let's graph these. Okay, that's my first one, that's my second one, and that's my third one. They kind of overlap there in the end. And if you ever want to zoom in, so watch this, I can like move this up and click like, maybe I'll move it down a little bit. I'll move it right where all the action's going on right there, and click zoom in. All right, so I'm able to see that was the first one. This is my second one. Looks like they go through the same point there. And then this is my third one. All right, so we notice that these are trending upward, right? From the left to right, notice how you're trending upward. If you were like investing in stocks, or you see some sort of change in polling, collecting data, and you see this is called exponential growth. And we'll talk further about exponential growth as well as exponential decay. But whenever you see y is equal to 2 to the power of x, okay, that's an equation for exponential growth. You will see these lines move on forever and ever and ever in that direction. They will continue to grow, moving upward, trending upward. Okay, that's exponential growth. You see all these from left to right, it looks like the y values are increasing. On the flip side, if you were looking and you saw a shape that moved down and slowly going towards 0, that would be called exponential decay. And there's many real-world applications of exponential decay and exponential growth. Exponential decay, just the first thing that comes to mind is maybe the value of your car, right? The value of some sort of depreciation of assets. Okay, and exponential growth could be your mutual fund. Hopefully, you're able to make a lot of money based off of an investment. Okay, so if you were to look at, I'm just going to go ahead, even though this isn't one of the problems, if I were to say like y equals 1/2 to the power of x, right? Look at the difference, see how that kind of moves trending downward. That's from the left to the right, that's called exponential decay. So growth, 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 decay. All right? And we're going to keep moving on. We're going to go through 10, 11, and 12. All right, we're going to take a look at number 10. All right, and number 10 is y equals 129 times 1.63 to the power of x. All right. Now, we're going to do something different. We're going to look at all three of these all at the same time. So we'll also look at number 11, and we'll also look at number 12. All right. So number 11 is y equals 2 times 0.65 to the power of x, and y equals 0.45 times 3 to the power of x. Okay, so the directions tell me, say, without graphing, determine whether the function represents exponential growth or exponential decay. Okay, so we want to see exponential growth or exponential decay. Okay, then, so that's step one. Step two is to find the y-intercept. All right, so the way I would do that is first, let's find exponential growth and exponential decay. And the way you would do that is by looking at this number right here. Okay. Is this number greater than 1? Okay. And if that is true, if it's greater than 1, then it's going to be exponential growth. If it's less than 1, right, from 0 to 1, then it's going to be exponential decay. So this number is greater than 1 right here. So this is going to be exponential growth. All right, number 11 is going to be exponential 0.65. That is less than 1, so that's decay. So without graphing it, I know that this is going to be an exponential decay. Exponential growth moves upward like that. Exponential decay moves downward like that. Exponential decay, exponential growth, right? And then in number 12, 3 is greater than 1, so that is exponential growth. All right, that was the first step. Second step says find the y-intercept. That's easy in these problems. The y-intercept is just going to be this. The reason why is because that when you raise 1.64 to the power of 0, right, when I'm graphing, right, and let's say I have a function that looks like this, and I graph it, and I'm looking for the y-intercept where I've crossed through the y-axis. This is my y-intercept right here. That's where x is equal to 0. So if I set x equals 0, 1.63 to the 0 power is 1. 1 times 129 is 129. So the y-intercept, remember we write y-intercept as b, right? The y-intercept is actually 129. All right. In this case, right here, my y-intercept is 2. Okay. And then for the last one, my y-intercept is 0.45. Because if I raise 3 to the power of 0, that gives you 1. 1 times 0.45. Anything times 1 is itself, so it's 0.45. All right, so This was the answer to number 10, this was the answer to number 11, and this was the answer to number 12. All right, I'm gonna go through numbers 13, 14, and 15 here. So if I click Y equals and I clear out all of this, and I go ahead and just say Y equals negative, this is for number 13, Y equals negative 5 to the power of X. Number 14 is exponential decay. I know that because I have 1/2 to the power of X. Any number between like 0.999 repeated all the way up through, or sorry, all the way down to 0, any fraction of a number is going to give you exponential decay. All right, and then number 15, I have 2 times 4 to the power of X. And number 16, I have 3 times 2 to the power of X. And then if I graph them, whoops, let's click zoom. Move out of there. It's gonna take its time. I'll have to wait. All right, so if I click zoom and go down to 6, what happened there was I was zoomed in really far. All right, so you see some exponential decay, some exponential growth, right? And even in 1, we have a negative number that goes downward, right? Okay, so just taking a look at this, in each of our functions when we graph them. So if I were to look at my table here, I'm able to see all the plotted points that I moved to the right. I can see Y3 and Y4. So I'll move back to the beginning and go back to my graph. Okay, I've went ahead and plotted each. It's important to identify which ones are exponential growth and exponential decay. All right, and those are numbers 13 through 16. And moving on, for the last 3, we are going to go ahead and graph these as well. I'll clear these out. This is for numbers 17, 18, and 19. And we are asked to graph each function as a transformation of its parent function. So first, I have a number 17. Let's look at number 17. I have 2 to the power of X. And I'm going to go ahead and do this. I'll say 2 to the power of X. And then I'll add 5 on the end. The reason why I added parentheses is just to make sure that we are actually performing that operation first, instead of saying 2 to the power of X plus 5, right? That's not what it actually is. It's 2 to the power of X and then plus 5 afterwards. All right, so I'm going to go ahead here and take a look at this, and by identifying that, I know that my parent function is going to be 2 to the power of X. All right, that's what I started with, and then I added 5 afterwards. So I'm going to go ahead and graph this and take a look. All right, so that's the function that's been transformed, and then this is my parent function. So you can see that the function was moved up 5. 1, 2, 3, 4, 5. And that's why we added 5 on the end. If I would have added 3, it would have been moved up 3. All right. And then for number 18, we'll do 2 to the power of X minus 5. And I'm just going to go ahead and do the same thing. I'll say 2 to the power of x, my parent function. I'm going to put this in parentheses, 2 to the power of x minus 5. And notice when I subtract 5, that's going to move it down 5, right? So from my parent function, as we've talked about parent functions the entire year, right, I have my parent function, I'm able to move it down, transform it down 5 by subtracting 5 from it, okay? And that is homework number 22. If you have any questions, please let me know.